This is the lesson for Chapter 5, Section 3, titled Solving Systems of Linear Equations by Elimination. So let's take a look at our first type of problem here. So it says you sell lemonade for $2 a cup, orange juice for $3 a cup. You sell a total of 100 cups for $240. And so we're going to try to write an equation and solve it using elimination. We're going to try to find the number of cups of lemonade, and we're also going to find the number of cups of orange juice. So we had to define some variables. And so let's do this. Let's say L equals the number of cups of lemonade, and we'll go with J equals the number of cups of orange juice, OJ. And so what we're going to do is try to write an equation to match the other words that they have. So it says you sell a cup of lemonade for $2. And so a cup of lemonade, L, times the price, $2, is going to give us the amount that we're going to end up selling of lemonade. And so here it says that orange juice costs $3 a cup. So we have plus the number of cups of orange juice times by the cost equals the amount of money that we made on orange juice. So if we add these two together, it says that we made a total of $240. Now we still have this 100 cups. It says that we have a total of 100 cups that you sell. Well, total means you're adding numbers together. We're adding the number of cups of lemonade plus the number of cups of orange juice, and it's going to equal a total of 100 cups. And so this is a great expression. This is a great system for elimination. So elimination again works this way, where if we take one of these expressions, we can cancel out one of the variables. So let's go ahead and multiply the second equation by negative 200. So every number there gets multiplied, or negative 2 I should say. Negative 2L plus, or actually I'm going to put a minus 2J. You can put plus negative, it's the same thing, equals negative 200. So that's what the new equation is. I'm going to take this top equation and put it down below. 2L plus 3J equals 240. So when you add these two equations together, we get a variable to cancel, and that's what we want to happen. You see the L's are going to cancel out, leaving me just with a J. So I have one J left over here, because 3 minus 2 makes 1. And then 240 minus 200 gives me 40. So there it is, juice, J. The number of cups of orange juice is 40. 40 cups of OJ. And so if I want to find out the number of cups of lemonade, I'd have to take that 40 cups and substitute back in. So I'm going to put it into this quantity equation that I had. So I'm going to have L plus 40 equals 100. So if I go ahead and subtract the 40 from all sides, that would give us how many cups of lemonade I'd have. So it looks like it's 60 cups of lemonade. So again, we can verify our solution by substituting that answer back into the other equation. Let's see if it works. 2 times 60 plus 3 times 40 should equal 240. So this is just our check here. So we're assuming this is right. We'll know for certain in just a moment. 120 is what we get there. 120 here as well. And that equals 240. So 120 and 120 do make 240. So when the numbers agree like that, we know we did it correctly. Let's take a look at another type of problem. So it says here that you have a total of 42 math problems. So total again, 42 math and science problems. So total means you're adding two numbers together. So it says that you have 10 more math problems than science problems. So how many of each do you have? And so let's start off with some variables. Let's say M equals the number of math problems, and we could go with S being the number of science problems. And so we'll start off with our quantity equation, which is going to be M plus S equals 100. So the total number, total means the sum, a sum of values, and that's what this is. The number of math problems, number of science problems, totals 100. Now they're going to be comparing. So here they're comparing. So we're comparing math problems to science problems. It says there's 10 more math problems. So the math problems equal the number of science problems plus 10 is what that says. This is actually a good one for substitution, but we're going to use elimination on this problem. So I'm going to subtract the s from both sides to get the variables by themselves. And so now I have m minus s is going to be 10. The difference of the math and science problems is 10 problems. Well, I have the original equation of the sum. M plus s is 100. So the number of math and science problems add to make 100, but actually not add to make 100. Let's fix that right now. They add to make 42, it says. I was thinking of the last problem there. So the number of math and science problems subtract to make 10, but add to make 42. So you see, if I add these two equations together, the s's, the sciences, will cancel out, leaving me with 2m equals 52. So if I divide by 2, that'll give me my answer. So I end up with m at 26. So 26 math problems. And now we have to figure out how many science problems. So if I just substitute back into that equation that I had before, so I'm going to use the m equals the s plus 10. I can go ahead and put 26 in place of m, and then just subtract the 10 from both sides. That's going to give me how many science problems I have. So it looks like it's 16 science problems. So 16 science problems. So let's move on to the last type here. The last example, it says that a landscaper buys 4 peonies and 9 geraniums for $190. And so another landscaper buys 5 peonies and 6 geraniums for $185. Write and solve the system to find the cost of each peony. So that we're just trying to find the number of peonies we have, and we'll start off with an equation. Let's go ahead and define our variables. We'll say P equals the cost of a peony and we'll say G equals the cost of 1 geranium. So now let's set up our equations. So one landscaper bought 4 peonies and 9 geraniums. So 4 times the cost of peony plus 9 times the cost of geranium is going to equal $190. And so another landscaper buys 5 peonies and 6 geraniums, but only spends $185. And so now we want to solve. And we want to find, it says, the cost of a peony. So we want to be able to cancel out the g's here. And so I'm going to go ahead and multiply this top equation by -2. So the reason I multiply it by -2 is because I was looking at the 9 and the 6, and I want to come up with a least common multiple. And so what that's going to end up being is 18. See, 9 times 2 makes 18, and 3 times 6 makes 18. So I'm going to just keep the 3 positive here, and I'm going to go ahead and multiply. So I'm left with this. I've got -8p, and then minus 18g equals, and then I need to double 190, so that's going to give me 380, -380. And then I do the same thing over here. 15p plus 18g equals, this makes 15. 24 and 1 make 25. Carry a 2, so that's going to be 555. So I go ahead and add these numbers together, and I end up with a 7p equals, and then I'll do the subtraction, 555 minus 380. So that's going to give me 175. And so now I just have to divide by 7, and I'll get my answer. So that's $25. How many times 7 goes into 175? 25, or 7 quarters makes $1.75, so that is correct. So peony costs $25 for each peony. And if we wanted to find the cost of a geranium, it's not asking for that, but let's say if we wanted to, we just have to substitute that 25 back in for one of the variables. So if I do this one here, put it in for the 4p, so it's going to be 4 times 25 plus 9g equals 190. Let's see what that would end up being. So this would be 100 plus 9g equals 190. So if I subtract that 100 from both sides, I get 9g is 90. So dividing by 9 leaves me with $10. So $10 for each geranium, and the peonies cost the $25. So those are the types of problems that you're going to see on tonight's homework. Good luck.